Ah, devlogs. If you're watching this one, then you probably watched the first one. Or if you didn't, you probably should. This will make more sense. So as not to bury the lead, the alpha for the mod is out. If you want to play it, you can go download it from the mod portal inside of Factorio. It's still in an alpha state, which means it's going through balanced revisions, so do expect some changes, but right now I would consider it to be in a fairly playable state. When I was younger, I would play shareware games like Commander Keen. Some games came with level editors, and often I would make levels for them. I don't remember which was the first one I did. The games were usually very small and kind of easy to forget after a while, and it's been decades. But I do remember my favorite, Duke Nukem 3D and the Build Engine. Our computer lab, which had just been upgraded from 286s to 486s, could play Duke Nukem 3D just fine. So we downloaded it to every single one of them and played during lunch. Damn, I'm looking good enough to make a sequel in maybe a few years with gameplay elements that expand on the FPS formula in faithful but innovative ways, giving me space to develop into a fuller version of myself with endearing action hero bravado, while remaining relatable and admirable through feats of will and self-sacrifice in epic moments with crescendoing stakes, instead of becoming a sociopathic caricature of an action hero in a game developed over an entire era of FPS action titles. Engine hopping driven by FOMO, in which devs bonesaw off vestigial organs of innovative titles and feverishly sew them together in a poorly thought out limb amalgamum fit only to slime around a zoo exhibit to serve an example of what not to do with an IP. I don't even know who to be mad at here. That was my first real exposure to the development cycle. We would play a level I'd made, it would suck, I would go home and tweak it, and we would try again. I could only do this so many times before we stopped wanting to play that level, but it taught me some good and bad lessons about the development cycle. That brings me to my second point of ethos. The development cycle is the development cycle is the development cycle. Though the details will change from project to project, the general idea is the same. You make something, you analyze it, you make changes, you analyze the changes, you make changes, you analyze the changes, and so on and so forth, until you determine that it's time to stop. The hardest cycle to get through is the first one, and I had that problem myself. My best advice is to take inspiration from the different disciplines. Writers will start with an outline, and when they get to the rough draft stage, they're willing to make really big changes to the story because they know they're going to double back and fix things later. 2D artists will often start with a rough sketch and fill in the details, well, however their particular style dictates. 3D artists often start with a rough blockout and add detail as they go on. Level designers start with an empty world before they start filling it. Movies start with screenplays. Composers can start by humming just a few bars. And programming projects like games start with a minimum viable product. You want to find out what doesn't work as quickly as possible. That is to say, you want to fail fast, particularly before you put in a whole lot of effort. So generally you throw something together just to see what it plays like. You keep the parts that work, you chuck the parts that don't, and you don't really break out the good programming principles, the ones that take time and thought to execute properly, until you're making something that you intend on keeping and extending. And that applies to everything. The graphics, the sound effects, the plot, everything is developed with this cycle. And you'll see a bunch of examples throughout the video. Let's start by looking at the icons for the stocks. In the first devlog, I promised I was going to change them from perspective to orthographic, and I did, but that wasn't all I did. On the far left is where I started, and on the far right is where I ended up. Each column here represents something that I tested in-game. From the first column to the second, you can see I changed from perspective to orthographic. That is to say, there are vanishing points in perspective where lines tend to draw together, as you can see with the girder here. But in orthographic, there is no sense of depth. But that wasn't quite enough. I put those on belts, and they didn't seem to be laying flat. So from the second to the third column, I went into Blender and rotated them until they were parallel with the ground. Seen up close like this, you can easily tell them all apart, but this becomes harder when they're on a belt, and the square stock, girder stock, and angle stock all look kind of the same from a distance, so I turned two of them. Lastly, they all felt like they had different brightnesses, and some of the geometry details getting lost. So from the fourth to the fifth, I added some distinction lighting. On the gears, you can see I lit the edges, and for the fine pipes, I raised the brightness a bit. I did that same process with the machined parts, but using what I did with the stocks as a model, I did all of them at once. For some of these, the difference between perspective and orthographic is pretty big, but they're also brighter and shinier, and I think that makes them look a lot better. Side note, I'm also planning ahead a bit here. The color of the icon maps to a property of the machined part, and at some point, I'm going to have machined parts with more than one property. That means I need to use two colors, and I'll probably use that shiny bit as the dividing line. Future me here, so it turns out that it took me so long to make this video that I did in fact do that thing. It's in the game, and you can go play it now. Let me pause here for a second and talk about the development cycle for this icon art. I essentially started with plates, and the metals had solid colors. Even though they weren't good enough to be a final product, I still ran with them at first. When I figured that adding in oxidation would solve a lot of problems, I not only redid them, I reorganized my Blender file so that I could rapidly make new versions. I go into more detail in the first devlog if you're curious. The reason I mention this is because at different points in the cycle, I had different expectations of what the art would do. I kind of like to think about it in terms of what it was good enough for. It started out being good enough for proof of concept, then it was good enough to share, then it was good enough to playtest, and at this point I think it's good enough to release. That doesn't mean it's eternally out of the development cycle, it just means that unless I have a compelling reason to, I don't need to revisit it, but I am always willing to. Whether for your own mod or your own game or some other completely different type of content, I highly recommend that you look at all assets that you make for your project through this lens. It'll not only help you get unstuck from decision paralysis, it'll give you signposts, or metrics, to help inform decisions about what to work on next. The next thing I want to talk about are ores. At this point in the design cycle, I've decided to make one ore for each type of metal. The plan is to make the ores distinct in two different ways, color and shape. For right now, I'm focusing on color distinction, but just like the stocks and machined parts earlier, I'm going to update all the ores to make them shape distinct as well. Right now, I put them at good enough to playtest. The way Factorio stores images for its ores is in what are called sprite sheets. I used the sprite sheets that came with the game as a sort of template. Each sheet is 8x8, and each image is 128 by 128 pixels. The sprites at the top represent tiles that have the most ore, and the sprites on the bottom represent the ones with the least. For any given ore density level, the game randomly picks one of the 8 images on a given row. My job then was to use Blender to make procedurally generated images. I set it up so it would make a new one every single frame, and then I just let it play for 64 frames, and stitched it together in a tile sheet after. To do that, I used geometry nodes. I started by creating a grid, then I put a bunch of random points in that grid, which would later be used to spawn rocks. The seed value for each frame depends on this number here, which is unique to each mineral, but also the frame. I've keyframed seed value here so that it counts up once per frame. Then, depending on what frame it was on, I cut away some of those points. Remember, we want the number of rocks to dwindle every 8 frames so that each row has fewer rocks than the one before. I spawned some cube rocks, then I made myself a custom node here. I'm not going to go over it in too much detail, but essentially what it does is it just randomizes the surface of the rocks so that they look a bit more organic. Once I worked out the random generation of the rocks, it was then time to move on to the veins of metal. I did this in a couple of stages. The first and most complicated one is this mess right here. What you're looking at is filtered 3D Perlin noise. I have a video explaining Perlin noise on my main math channel if you want to go check it out. Link is in the description, but the quick explanation is that it gives you smoothly connected blobs of noise, and by filtering out parts of it, you get this nice network. The downside is that this is very difficult for Blender to calculate, which means a couple of times on stream when I was doing this, I would hang the stream and have to wait until it was done rendering. To see that and other mistakes, click on the link in the description below to come follow me on Twitch. I've also been told that I'm very bad at promoting myself, so here goes. I have a Patreon, and there's also this new channel membership thing for YouTube. Don't feel like you'll be missing out on anything if you don't, because I'm always going to be releasing my content for free. So if you want to support me, you'll be doing so out of the goodness of your own heart. Though there might be emojis. The second part of adding metal to these images came in the form of pebbles. It uses roughly the same logic as I did for the rocks, and because I was clever in how I designed the nodes, I just changed a couple of input numbers and it made them much smaller. The next bit of detail was the dust layer that I put on the ground. This is both to give it some character and to make it easier for each sprite to blend in with whatever terrain is underneath it. You'll notice that up close this looks really jank. However, when you render it, it looks just fine. The reason is because this is getting pixel crushed. I essentially tuned this to be roughly 1 pixel big. With all of that in place, the last thing to do is to make sure the colors are unique. For the different metals, I used the same colors I did with the plates, mostly. For whatever reason, on the ores they looked a bit washed out. So for many of them, I increased the saturation a bit. The real challenge was coming up with colors for the rock substrate. Essentially, I've got 3 colors vying for the player's attention right here, and it gets a bit busy. They essentially need to look different from a distance so that if 2 patches are right next to each other, the player can easily tell them apart. For the most part, I think I did a pretty good job, but considering how many other metals I have planned, well, let's just say that I've got some more work to do here. At that point, technically the patches were complete enough to be used in-game. But I had an idea. This is obviously a uranium ore patch seen at night. As you can tell, it's glowing more than John Delancey when presented with a stoic starship captain. It turns out that Factorio has a second sprite sheet that you can use with ores. In this case, it's effectively a glow sheet. But that's not all it can be used for. What if, instead of using it for glowing, I painted sparkles in that sheet in order to make it glitter in the sunlight? The Factorio devs put a couple of properties in the prototype for ore that can be cleverly used to enable this behavior. First, you can control the rate of the pulsing of this glow. Second, you can add in a couple of offsets so that it's not all pulsing at the same rate. And third, you can turn the effect on and off depending on what time of day it is. Originally, this was used so the glow would only show up at night, but I'm going to use it so it only sparkles during the daytime. The way I did it was in Blender, I rendered out just the reflection layer, and then I got rid of everything that wasn't bright enough. This left me with a couple of pixels. I took them into Photoshop, used both motion and regular blur, tinted them a little bit, and eventually got this. So far, copper is the only one for which I've done this, but that's because I can't do the rest of them until I do my pass for making them shape distinct. Still, as a proof of concept, I think this looks pretty cool. It's a subtle effect, but I think it adds something. Or items took a bit more time. I essentially used the same kind of idea, that is to say, I made a couple of random rocks, but because of the nature of what I was doing, I actually made a whole bunch of these things and just picked the ones I liked best. Or rather, doing this on stream, I let the audience pick. Because I want the ore to agree with the stock's colors, I left oxidation on the rocks as well. There are 4 variants, just like you would expect. And honestly, the thing that took me the most time was trying to light this properly. Suffice it to say that I got something that I'm mostly happy with, but it may be something I revisit in the future. The pro gamers may have noticed that there's another ore here, nickel. The reason I added it had nothing to do with nickel itself, but rather with an alloy of nickel. That is to say, Invar. Invar is a blend of nickel and iron, and the reason I need it is because of the property Invar has. In real life, it's called Invar for invariant, specifically thermal invariance. That is to say that it's particularly resistant to warping or expanding or contracting when exposed to high temperatures. When I went to redo the recipes in the vanilla suite, I found that it made a lot of sense to have something that was thermally stable. The reason I mention this is because I'm going with a sort of minimalistic approach to adding metals to the game. While I've made a bunch of art that I think will be useful later on, I'm only adding in metals when they're needed. Yes, it would be cool to have aluminum, but right now that metal doesn't fit any roles, so it's not in the game. That being said, aluminum is a good candidate for metal to be used in a compatibility pack. So that brings us to galvanized steel. Galvanized steel is unique for 2 reasons. One, it's the first treated metal, specifically treated by being plated with zinc. That's what galvanized steel actually is, and they do that to make the steel resistant to weathering so it can extend the life of the steel when used in outdoor applications. In game terms, it's going to allow you to turn steel into stocks that can then be made into machined parts that have the corrosion-resistant property. Yes, from a realism standpoint, if you machine a stock into something, you are going to remove a zinc coating. But trust me, I've thought of other solutions in-game, and it just gets really messy. Anyways, the treatment system is essentially your way as a player to add properties to metal stocks, which could potentially be very useful. Which brings me to the second reason it's unique, and that is multiple propertied machined parts. In this case, I'm thinking of machined parts that are both heavy load-bearing and corrosion-resistant. No other metal currently on the roster will satisfy that. The second treated metal is annealed copper. This adds ductility to copper and will be used for wiring. You'll also notice that treated metals don't have an oxide layer. This both helps with differentiation and gives a sense of progression as the stocks look more and more refined. I'm excited to talk about some of the Minisemblers. So you may have noticed in the first video that I had some items in my inventory which were essentially different colorized Minisemblers. That was the first implementation of them. I essentially just used Factorio's native tinting system to make icons and entity art so I could get the Minisemblers in the game without having to worry too much about if it looked good. After this proof of concept stage though, it was time to set things up so they could be extended. The first step of this was going into Blender, choosing a bunch of colors, applying that to the painted areas of this, and saving them with file names that were unique to each Minisembler. Then I wrote code that would procedurally generate the prototypes necessary for these things to run in the game, and did some other hacky stuff that I'll talk more about in the code part of this. The reason this is so cool is because now I can do a drop-in replacement for any of these placeholders, and we'll get a brand new Minisembler. For example, I've got the bandsaw and the welder. I'm not going to go into too much detail about how I made these. If you're interested in seeing how I do it, I made both of these entirely on stream, but suffice it to say there's a bunch of Blender techniques involved. Also, I'm kind of wondering whether or not I should continue making the Minisemblers for the metalworking phase, or if I should start working on other content for the other phases, like stone, wood, and all that stuff. Long term, I don't really have an answer, although short term, I'm just going to keep making the Minisemblers. If you have any thoughts about what you'd like to see next, let me know in the comments. Beyond that, there hasn't been a lot of work graphically. I made some icons for the technologies, I prepared a couple of infographic flowcharts for the website, and I tuned the property icons a little for those that need them. And that brings me to my next topic, options. I'm going to be talking about the options I've implemented, why I implemented them, why I chose not to implement some others, and I'm going to use it as a segue to the code side of things. Options are tricky. They're essentially design choices, and either you make it as the dev at design time, or you ask the player to make it at game time. The more options you make, the more choices the player has to shape their experience, but also the more overwhelming it can be for the first-time player. For that reason, I want to be very careful anytime I'm considering making something an option. To help with that, I have a particular way of looking at it. Broadly, options fit into two categories: accessibility and presentation settings, the kind of things you generally find under graphics or audio for various games. Changing these settings shouldn't appreciably change the gameplay. Options that do fall into the other category, gameplay settings. There's not always a perfect division between the two. As an example, consider Valheim. In the graphics settings, there's a vegetation quality slider. If you slide it up, the game looks nice. But if you slide it all the way down, then yes, you're making the typical exchange between visual quality and frame rate, but it's also easier to see certain things in the ground that you might have otherwise overlooked, which can impact the gameplay. As a side note, if you like Valheim, I've made a few build tutorials on this channel, and I'll link them in the description. Accessibility options are... Hang on. Accessibility options are pretty easy. If it makes sense that someone's going to need it, put it in. Gameplay options require more consideration. Some settings, just by their very name, contain spoilers for the mod, and while they're generally pretty mild, you may want to be aware of it if you're making your own.
Should your final boss, Gulvar, Destroyer of Planets, have the blue or red health bar?
Another big problem is asking the player to make a choice about something they have no context for. If you introduce a new type of resource, but then ask the player to make a choice about how it behaves, you're essentially saying, hey, your gaming experience is going to be dependent on this educated guess you're making. Remember, they're already making an educated guess and playing your mod in the first place. That doesn't mean don't give them options. Just make sure you have a good reason when you do so. Right now, the option I'm thinking the most about is the first of my difficulty options, and that is advanced versus simple mode. Just calling the option either advanced or simple isn't necessarily good enough to communicate to the player what the implications of that is. On the other hand, I also don't know what else to do. I do need to have some kind of difficulty settings here. So let me do a quick job of explaining what it means. Essentially, simple mode focuses mostly on the machined parts, whereas advanced mode focuses both on the machined parts and the stocks that lead to them. It's going to be much harder to bust things in advanced mode, and most processing steps that lead from plates to machined parts will have 3 steps, though a couple will have 2. Whereas with simple mode, most will have 1 and a handful will have more. The game defaults to advanced mode, but if you're playing and you're finding it very tedious, give simple mode a shot. It may mean that you need to start over again, but you also might find it more enjoyable. And if you don't think I should be defaulting to advanced mode, do let me know in the comments. That's a thing I'm looking for feedback on. So the code. The first thing to understand about Factorio modding is the data lifecycle. There are 3 big stages to how Factorio loads mods and other content: the setting stage, the prototype stage, and the runtime stage. The setting stage is exactly what it sounds like. You expose knobs for the players to tune their experience. The prototype stage is where you define all the stuff you want to exist in the game, so items, entities, technologies, all that good stuff. And the runtime stage is where you write scripts that actually get run during game time, and those change the game state. My mod primarily lives in the setting stage and the prototype or data stage. As such, I'm not going to be talking about the runtime stage in this video. At some point, if I know more, then I'll talk about it then. The environment I use to code in is called VS Code, and it's free and available for both Mac and PC. I installed an extension called the Factorio Maker's Toolkit. This is written and maintained by Just a Random Geek, so go check that out. While it's not a hard requirement, I can tell you it will save you a lot of time, and it'll help teach you incidentally about the inner workings of Factorio by telling you what to and what not to do. Another useful thing for modders is the API documentation. I've got a link in the description. At the time of recording, they're in the process of updating to a new format, but that process isn't complete, and so sometimes you'll see links that take you to the old website. As often as you can though, use the new website as it has the more up-to-date information. Okay, so here's an example. This uses data extend, which is a helper function. What it does is it essentially adds something to data.raw that contains all the information that's been uploaded so far from vanilla or whatever mods came before this, and where you're going to be putting all of your stuff so it can be used by Factorio at runtime. The way it works is that you package all of the information you need for a single prototype in one of these tables, which is contained inside the curly braces here. Most importantly, the type here says technology. This lets Factorio know that all the rest of the data you have here is to go into a technology prototype. What some of these things mean are pretty obvious. You get name and icon and all that good stuff. What all of these do is contained inside the API that I mentioned earlier. If the property is listed as optional, you don't need it, but it would be very odd not to have some of these, like a technology without an icon. You may also notice that name doesn't appear up here. That's because it appears down here. Technology inherits from prototype base, meaning it inherits all of its properties too. This is an important lesson. Consider assembling machines. There's an entire chain of inheritance here, and some of the properties from parent prototypes are not optional. So just make sure you're checking that when you go to make these. Now a little bit about Lua. One of the big data types in Lua is the table. You may already know this data type from other languages, a dictionary, and it uses some of the same terminologies. You have keys and values. You hand the dictionary a key, and it will return to you a value. If you don't give the table any keys, it'll essentially treat it like an array, where the keys are indices starting with 1, not 0. Good times. So as I said before, Lua is a scripting language. One thing to note is it has a lot of syntax sugar. My experience personally was that it was very difficult to find out how some of this stuff worked because I didn't often know the search term I needed to use in order to find out information on the piece of syntax sugar I was looking at. To solve this, I essentially used the community, and again, I'm going to recommend that you do that too. So that should be enough to get you started. With that in mind, I'm going to go to a high-level explanation of what I did with my own code. As I mentioned in my last video, I'm utilizing tables here in order to do most of my data entry. Then I have code in this file that takes those tables and procedurally generates the prototypes. There's quite a few of them that need to get made. Obviously, there's the items and the recipes and the entities, which are the placeable things in the world, in this case, Minisemblers. But there's also the technologies, the prototype for this tab here, the prototypes for the subgroups, and under the hood, the prototypes for the crafting categories. I use this to separate things out so each Minisembler has a unique set of things it can make. But boy, there are a lot of special cases. There are iron plates in the free play scenario that show up on the crashed ship. Those had to be replaced with iron plate stock. Because I have alloyed smelting recipes that include more than one ingredient, like for brass and Invar, I took a page from Factorio 2's book and replaced all the furnaces with assembling machines that basically look and behave exactly the same way, except you have to manually set the recipe for every single one, and evidently that also means the output slot won't hold a full stack of iron plates, meaning you have to babysit them more. But it also means that Factorio won't load. You have to have at least one furnace prototype. So we put in one. It was basically a dummy prototype, and it contained the minimum amount of information you would need to still have Factorio run. In fact, it was so minimal that it actually broke other mods. This is actually a good thing. It taught me a bit more about the engine and a couple of other mod authors, including Theranos, thank you for being so graceful about it, to account for the cases when you might have a furnace that has no bounding box, for example. It also turns out that the player needs to be able to make certain things by hand. Otherwise, they can't bootstrap. If you can't make brass into corrosion-resistant pipes, you can't make pipes, meaning you can't make steam engines, meaning you can't make electricity, meaning you can't power a lab, meaning you can't research minisemblers, which would otherwise be necessary to make those things. I had a few solutions. I could give the player a couple of corrosion-resistant pipes on the crashed ship, but then they can still deadlock, through no fault of their own, if they consume them on things that aren't making electric power. I could give them a steam engine in the crashed ship, but why would they have one? I mean, for all I know, you do drive around with a steam engine in the back of your car. I don't know, who am I to judge? Anyways, the solution I went with wasn't so much the best as much as it was the least worst. That is, I gave the player the ability to make a couple of things, just enough so that they could bootstrap. The other big one was the electrically conductive wiring, not replacing copper cable, which doesn't sound like a big deal until you realize that that means you can no longer connect up power poles. So I had to go fix that. Also, pipe is special, so when I replaced pipe entirely, it turns out that there weren't any pipes you could put in the world anymore, so I had to fix that. It turns out that productivity module support is not built into all recipes, and instead you have to actually manually set those things. So I fixed that. Most of the rest of the problems were me failing to test my mod properly. That is to say, making it work for either simple or advanced mode but not the other, or making it work for high resolution mode and forgetting about normal resolution mode. I've basically turned off expensive mode entirely at this point, although I do plan on implementing it in the future, but I'll do so when I implement the other modes I have in mind. If you've been listening carefully, you probably know what I'm going to say next. This is the development cycle. This isn't the only reason I'm calling this alpha, but this sort of phenomenon is on that list. That being said, massive shout out to the brave souls who've given this thing a shot. Your feedback has been absolutely invaluable, and I still have my list of things that I'm working on for the future, so please continue giving that feedback. And that brings me to my last topic, the re-recipeing phase. This is where I take all the recipes from vanilla Factorio and reimagine them using my own intermediates. It's not as simple as it sounds. I can't just take all copper plates and replace them with, wiring, because copper plates used in power poles probably turn into something different than the copper plates used in, say, bullets. So I really do have to go in there and do all of it by hand. I did this in a couple of stages. The first thing I did was I typed up a whole long Lua table. All I put in this table were the elements that I was going to add to the recipes, putting corrosion-resistant items in things that have fluid boxes, using lead in things that involve nuclear power, that kind of thing. The first pass, I didn't even worry about what the counts were,
For the second pass, I tried to make the resource count from vanilla Factorio roughly match what it was going to end up being in my own mod. But then my item count exploded, because at that time, my intermediates didn't really get any denser as you processed them. One plate led to one sheet led to one gear, whereas in vanilla Factorio, one gear is 2 iron plates and one steel is 5 iron plates. So I wrote a script that essentially dumped all of my recipes into a CSV file, which is a comma-separated values file, essentially something I could use in Google Sheets. I did the same thing for all vanilla recipes that had one of the intermediates that I was going to be replacing, like the iron sticks and plates and gears and wire and all that good stuff. I pulled them into Google Sheets, matched everything up, and then did some math. I built cells that would allow me to change the ratios of stocks and machined parts being made. I broke out columns for 2 of each type of machined part. I summated those things over here, and now all I had to do was to type in numbers to these things and check against the final totals over here so that things matched up roughly. I did err on the side of making things a little bit more expensive. Consider that I'm giving the player more resource patches, but not making the ones I already had any smaller. Once I was happy, I saved it as another CSV file, wrote a Python script that would turn that into a Lua table here, and then used that to do the actual re-recipeing process. Do bear in mind, I didn't touch every recipe. Some recipes that use copper plates still do. There's 2 reasons that could be. One, I have plans to do that in a later pass, like the copper plates used in green circuits will eventually be redone when I do my electronics pass. Or 2, it's one I haven't quite figured out what I'm going to do yet, for example, the combat items. For those kind of items, right now I just have a flat replacement. So copper plate gets replaced with copper plate stock, copper cable gets replaced with electrically conductive wiring, that sort of thing. It'll get changed at some point, but that's the development cycle, baby. Future Galdoc here. These videos take so long to make and edit that something actually happened during the video development cycle. Ooh, meta. Space Age was announced, the official expansion for Factorio, and it's due in about a year. That also means that Factorio Friday Facts are back up, and in number 375, the quality mechanic was announced. I made a small video responding to that, link in the description. The big takeaway is that I would like to use quality upgrades to incentivize making particular parts out of different metals. This could take out a lot of the RNG and give a meaningful use to all the different metals that are introduced in many other mod packs. However, there was one detail that I didn't realize until after I published, and this one is potentially even more game-changing. Take a look at this animation. Did you see it? This is an assembling machine that can actually place its product on the ground in front of it. This didn't exist before. Mining entities were the only ones that could do this previously. What this means is that in like a year, I can make mini-assemblers that feed into one another without having to worry about all the inserters. This is a really new thing, so I haven't really processed it or what its implications could be, so things will end up changing, and a year is a long time, let's be honest. But it really is exciting. I can't wait to see what happens next week. Or maybe this week. I don't know how many of these things I'm going to see before I actually get this video out. You know, I should probably go edit this video. Thanks for watching. Thank you to everyone who's pitched in. Thank you to my supporters on Patreon, Twitch, and everywhere else. Take care of yourselves, be good to each other, and I'll see you in the next one.